Welcome back, everyone. So today we're just going to be doing a very basic and quick um, number theory problem, or proof, I should say. And the question is: show that all square numbers have an odd number of divisors or factors. Okay. So this is pretty basic. So we're going to be using one important tool today, and here's our tool. So it's for any polynomial, for any number n, where any integer n, wait, how should I write this? So, yeah, any integer, any positive integer, where, so n is any positive integer, and so n can be expressed as a product of its prime factors. So, in its prime factorization, p1 e1 times p2 e2 all the way to pn pk ek. Okay? Then let's define uh, then let's define t of x as some function which outputs number of factors of of x, and we have that t of n is nothing but e1 plus 1, e2 plus 1, all the way to ek plus 1. And that's basically, this just gives you the number of factors of n, any number n. Okay? And the proof of this is pretty basic, or just the intuition behind this, because whenever we have like some kind of number, 24 for example, equals, well, this is just 2 cubed times 3. Basically, in order to find all the factors, we have 4 choices for 2. We have 2 to the 3, 2 to the 2, 2 to the 1, and 2 to the 0, and we have 4 choices for 2 and 2 choices for 3. We have 3 to the 1 and 3 to the 0. So in order to get all of the factors, we just multiply, well, the number here, which is 4, the number of values here, which is 4, by the number of values here, which is just 2. So we just get the number of factors here is 8. And notice that all we're doing here is just multiplying 3 plus 1. There's going to be 3 plus 1 factors here, possibilities here, and 1 plus 1 possibilities there. And this just equals 8. Okay? So there we go. So that's going to be a very useful tool. So we're just going to get rid of this. Okay. So, yeah, so let's take any number, let's say any number n. We're just going to use this value n here. Okay? So n equals p1 e1 times p2 e2 all the way to pk ek. Let n equal, okay? Let n equal this. So this is the prime factorization of n. Okay? Okay, so, and we want to show that, well, we know that if we square both sides, then we'll get a square number. So n squared, this is going to be a square number, n squared equals p1 2 e1, right? Because, or essentially, I'll just write out in a more clear fashion. So we have parenthesis times p2 e2 all the way to pk ek. This is a lot of writing. Squared, and this is just equal to p1 2 e1 times p2 2 e2 all the way to pk 2 ek. E sub k, yep. And again, we can use this definition here to find the number of factors of the square number n squared. So we defined our t of n squared as 2e1 plus 1 2 2e2 plus 1 all the way to 2ek plus 1. Okay? And notice that this is just the form of an odd number. So this number is odd. And so is this number. And so are all of these numbers. And notice that odd numbers times odd numbers, an odd number times an odd number is just an odd number. Odd. As we've seen in the past, in our past Putnam problem. So, as a result, any odd numbers scaled by each other, this will just result in an odd number. As a result, t of n squared is just odd. There's our proof. Hopefully enjoyed, and have a nice day.